Alright, so today we are finally solving polynomial equations by factoring. And so yesterday we had a very in-depth review on how to factor. And so today we're going to be using that to solve our polynomial equations. So the first thing we want to do is make sure that all of our terms are on one side of the equal sign and that it equals 0. Then we'll factor the polynomial completely. Then we'll set each factor equal to 0 and solve. And so on number 1, we have x cubed plus x is equal to 0. And so because we did go over factoring yesterday and we do have multiple videos on factoring, I am going to kind of speed through the factoring portion and then just get into the solving problem. So we'll factor out the x. We get x squared plus 1 equals 0. Since 1 is a perfect square, but since we are adding, it is the sum of squares, which is not a special case. So then we set x equal to 0 and x squared plus 1 equal to 0. Subtract 1 from both sides. X squared equals -1. Whenever we have a square equals a negative, we are going to end up with imaginary numbers. And so the square root of a -1 is called I, which is the imaginary numbers. And so whenever we have the square root of -1, it is I. Whenever we have the square root of a negative number, we'll take I out and then simplify from there. So our zeros, our solutions, are 0 and plus or minus I. Now on number 2, we want to make sure that all of our numbers, all of our variables are all on one side and then it equals 0. So I'm going to move this 3x squared over. So I have 4x cubed minus 10x squared equals 0. 4 and 10 have 2 in common, and x squared and x cubed have x squared in common. So I'm left with 2x minus 5. So we'll set each factor equal to 0. Divide by 2. Square root. X is equal to 0. And then 2x minus 5 is equal to 0. And we'll solve that for x. And we get x is equal to 5 over 2. So x equals 0 and 5 over 2. On number 3, we have x to the 4th power minus 64. So this is a difference of squares. X squared minus 8, and x squared plus 8. We cannot factor further because 8 is not a perfect square. So we'll set each one equal to 0 and solve. So the beginning does say to simplify our radicals, I think. Let me double check. Simplify all irrational and complex solutions, yes. So we do have to simplify this square root of 8. That's something that we did in Algebra 1. And you can use menu number factor if you have your calculator. If not, you can draw out your tree. So 8 is 2 times 4, which is 2 times 2. and that's the prime factors of 8. So if you want to write it out as 8 equals 2 times 2 times 2, you remember that any pairs would come out to the front. So the square root of 8 would equal 2 square root 2. So we have 2 square root 2. And then let's do our other side. We had x squared plus 8 as our other factor equal to 0. We'll subtract 8 from both sides. X squared is equal to negative 8. Take the square root of both. We're taking the square root of a negative, so just be aware that an I is going to come out of there. X is equal to, we have I, well, we know that the square root of 8 is 2 square root 2, so it would be 2I square root of 2. So that negative on the inside becomes that I on the outside. So x equals 2 square root of 2 and 2I square root of 2. Number 4, 5x to the 5th power minus 80x equals 0. So we know they are both on the same side. They equal 0. We're good. So we're just going to start factoring. I'm going to take out a GCF. I can divide both of them by 5x. Leaves me x to the 4th minus 16. X to the 4th minus 16 is the difference of squares. So x squared plus 4 and x squared minus 4. X squared minus 4 is the difference of squares. So we have 5x, x squared plus 4, x plus 2, x minus 2. Now none of this can be factored any further because x squared plus 4 is the sum of squares, which is not a special case. So now we'll take each of these and set them equal to 0 and solve. So I'm going to be taking the square root of a negative. The square root of 4 is 2. So this is 2i, since we have to take that I out. Then x plus 2 equals 0. Subtract 2. X is negative 2. And x minus 2 is equal to 0. Add 2. And x is equal to positive 2. So x equals 0 plus or minus 2i, negative 2, and positive 2. So if you look back on the answers where we had i's, I did include the plus or minus. I didn't say it when I was writing it, but I did write plus or minus just because when we take the square root, we know that we can take the positive of it and the negative of it, and it is the same for our imaginary numbers. Now number 5, we're doing the same thing. We have x cubed minus 8x squared plus 16x. So I'm going to take out an x because I see they all have that in common. Two numbers that multiply to positive 16, but add to negative 8, negative 4, negative 4. So then we take each one, set it equal to 0. We have the same one again. And anytime you have something more than once, then it has a multiplicity. So we have x equals 0 and 4 multiplicity of 2. On number 6, my coefficients are 2, 10, and 48, and then my powers are 6, 4, and 2. So I know that I can take a 2 out of all of my coefficients, and I can take out a power of 2 since it's the smallest on all of my x's. So that leaves me with x to the 4th minus 5x squared minus 24 equals 0. So just like before on yesterday's assignment, if you need to let u equal x squared, then just go ahead and do that for the x to the 4th and the x squared. But it will work the same way as our 3-term trinomials. So here we're looking for two numbers that multiply to negative 24 but add to negative 5. We've got negative 8 and positive 3. X squared minus 8. 8 is not a perfect square. X cubed plus 3. 3 is not a perfect square, and that is a sum. So we're not going to factor any further. But we are going to set each one equal to 0 and solve. So x is equal to 0. X squared minus 8 equals 0. We add 8 to both sides. We get x squared equals positive 8. Oops. Take the square root of both sides. And we get x equals 2 root 2. We already know the square root of 8 is 2 root 2 because we found that on the other problem. And then x squared plus 3 equals 0. Subtract 3. X squared equals negative 3. Take the square root of both sides. Square root of 3 can't be simplified, but I will take that I out. So we get I square root of 3. So x equals 0 plus or minus 2 root 2 and plus or minus I square root of 3. Number 7. Remember, I want this to look like everything equals 0. So I need to move that 16 over before I can get started. We get 3x to the 4th minus 2x squared minus 16 is equal to 0. And again, if you have to say let u equal x squared, and then you've got 3u squared minus 2u minus 16, and that's easier for you to solve, then go ahead and do that. We'll have to slide and divide, so I'm going to move that 3 over with the 16. Get x to the 4th minus 2x squared minus 48. Now we need two numbers that multiply to negative 48 but add to negative 2. Those two numbers are negative 8 and positive 6. So we've got x squared minus 8, x squared plus 6. But remember, we multiplied by 3, so now I need to divide by 3. And so we have 3x squared minus 8. And 6 divided by 3 is 2, so x squared plus 2. And that equals 0. 3 and 8 don't have anything in common, and x squared plus 2 is a sum, So we cannot factor any further. We'll take each of these, set it equal to 0. And solve. We've got x squared equals 8 over 3. We take the square root of both. So that means x equals the square root of 8 over 3, which is 2 root 2 over the square root of 3. And so once we get to a step like this, we would typically want to rationalize the denominator. So we're going to take this and multiply by root 3 over root 3. And so we've got 2 root 6 over 3. So x equals 2 root 6 over 3. And then my other factor I'll write over here. X squared plus 2 is equal to 0. Subtract 2. X squared equals negative 2. Take the square root of both sides. And x is equal to I root 2. So my values for x would be plus or minus 2 square root of 6 over 3 and plus or minus I square root of 2. So that one was a doozy. So then we'll go to number 8, and again we want to make sure that everything is on the left side, so I'm going to move the x squared and the 1. I'm going to write them under the terms that they'll be combining with. These are going to cancel. So we have 5x to the 4th power plus 12x squared minus 9 is equal to 0. 5, 12, and 9 don't have a common factor, and they don't all have an x, so we can't factor out an x. So I'm going to use slide and divide. And so that gives me a new problem of x to the 4th plus 12x squared minus 45. So then I'm going to factor that. I need two numbers that multiply to negative 45, but add to 12. Those two numbers are positive 15 and negative 3. But remember, we multiplied by a 5, so I'm going to divide by 5. So I get x squared plus 3 and 5x squared minus 3. As my factors, that equals 0. So then from there, I'm going to set each one equal to 0. And solve. It's not squared anymore. X equals plus or minus I root 3. And then 5x squared minus 3 equals 0. And 3. 5x squared equals 3. Divide by 5. X squared equals 3 over 5. So once I see that, I kind of know I'm probably going to have to rationalize that denominator. So I'm going to need some more space. So we get x is equal to square root of 3 over 5, which is the square root of 3 over the square root of 5. So I'm going to multiply by the denominator on top of itself, which is the same thing as multiplying by 1. That way I know I'm not changing the value. But I know that a rational times itself will cancel out the rational and just give me that value. Sorry for the bell. And then on top I have the square root of 15. So that went from the square root of 3 over 5 to the square root of 15 over 5. So there's no longer a radical in the denominator, which is what we wanted. And so my values for x are plus or minus I root 3 and plus or minus root 15 over 5. Now, number 9, we have 4 terms, and none of them have anything in common. So what I'm going to do is factor by grouping, which is one of my favorite ways to factor. So we split the problem in half, and we take out the GCF from both sides. So the greatest thing between these two is an x squared, which leaves me with x plus 2. Between these is a 5, which leaves me with x plus 2. So my factors are x squared plus 5 and x plus 2. And then I'll set each of these equal to 0 and solve. X squared equals negative 5. Take the square root of both sides. X equals plus or minus I root 5, and then x plus 2 equals 0. So we subtract 2, and x equals negative 2. So my values for x are plus or minus I root 5 and negative 2. So the only times that it's plus or minus is whenever you've taken the square root of something, and then otherwise it's just that value. And then the only time when we have to multiply by the denominator over itself is whenever we end up with a square root in the denominator. So on number 10, we've got 4 terms again. We're going to split it down the middle and factor out the GCF of both sides. Greatest thing I can take out of these two is an x squared. I'm left with 2x minus 3. And over here, the greatest thing that I can take out of here is negative 16, which leaves me with a 2x minus 3. Remember, we want those to be the same, so just double check that they are. So my factors are x squared minus 16 and 2x minus 3. And so I'd be tempted to stop there and say, okay, let me set each of these equal to 0. But x squared minus 16 is the difference of squares. So that factors to x plus 4, x minus 4 when we take the square root of both, and then 2x minus 3. So now I'm going to take each of these and set them equal to 0. X is negative 4. X is positive 4. And x is 3 over 2. So when I write out my values, I've got negative 4, positive 4, and 3 over 2. So then for your homework, I want you to do the odds. And then turn those in on Canvas. So you're doing the odds only on the next 2 pages, and then you'll turn those in on Canvas for credit, and then I will see you guys next time.